In the middle of the previous century, flying saucers were constantly making headlines. America was going through a surge of reported UFO sightings. So, it shouldn't probably come as a surprise that the American authorities, namely the U.S. Air Force, created a couple of short-lived programs. Those were Project Sign and Project Grudge, and their main goal was to look into that phenomenon. These programs were followed by likely the most famous of them all, Project Blue Book. It was a large-scale government study that lasted from 1951 to 1969. The initiator of this program was Major General Charles P. Cabell. He was a former intelligence director of the Air Force. Project Blue Book scrupulously gathered over 12,600 reports about people seeing bizarre, unidentified objects in the sky. After thorough research, it was determined that most of those had natural, quite mundane explanations. As for the rest of the reports, the members of Project Blue Book simply didn't have enough data to evaluate them. That's why support for their efforts dwindled. Officially, Project Blue Book was closed in December 1969. But apparently, it didn't make American authorities lose interest in UFO sightings. Because in mid-December 2017, the world found out that they had secretly launched one more UFO research program in the late 2000s. Accordingly to certain documents, American authorities spent around $22 million over a 4-year span on a project called the Advanced Aviation Threat Identification Program, aka AATIP. This project was started in 2007, and its main goal was to study UFO phenomena. Most likely, all this activity was triggered by the 2004 Tic Tac incident. That's when a few U.S. Air Force pilots spotted unidentified flying objects off the coast of California. They captured them on video. None of the pilots could figure out what these objects were. They behaved in a weird way, as if our laws of physics didn't apply to them. They were reportedly flying extremely fast and rotating in unpredictable movements. It looks as if after that incident, American authorities decided to investigate whether those objects could be identified or not. And if not, they were eager to know where they had come from and if they had been a threat. When the New York Times story about the new project broke, officials announced that the study had been terminated in 2012. However, there were people who claimed that the program was still ongoing. One of those was a military intelligence official running the program until they quit in October 2016. In any case, let's have a closer look at this mysterious program. Indeed, the areas of research funded by the project resembled things you could find in Star Trek. For example, one grant was for the study of traversable wormholes, stargates, and negative energy. This study was conducted by Eric W. Davis of EarthTech International, Inc. Another grant sponsored the research of invisibility cloaking. One more area of study included warp drive, dark energy, and the manipulation of extra dimensions. This research was conducted by a theoretical physicist and director of the nonprofit Icarus Interstellar. As we've already mentioned, all these studies received at least $22 million of funding, but this sum could have been much bigger. No one has revealed why or how these studies were given such huge grants under the AATI program. The results of the study aren't known publicly either. The criteria for choosing these fields of research could be that warp drives and stargates might be useful for extraterrestrial civilizations traveling interstellar distances to visit our planet. Still, some people are not amused that such questionable fields of study were receiving substantial government funding.
The Roswell incident is a collection of events and myths surrounding the crash of a mysterious object in 1947. Right after rubber and metallic debris was recovered by Roswell Army airfield staff, the United States Army claimed that they had their hands on a flying disc. Just a day after this announcement was made and made international headlines, it was retracted, but the word was already out. To hide the true nature of the find, the Army stated it was a good old weather balloon. But later in 1978, a retired Air Force officer revealed that it was just a cover story. At the same time, He added that he was sure that the debris had an extraterrestrial origin. This speculation became popular thanks to the 1980 book, The Roswell Incident. It also turned into the basis for long-lasting and increasingly contradictory and complex UFO conspiracy theories. Over time, they expanded the incident to include authorities hiding the evidence of other space civilizations, multiple crashed flying saucers, alien bodies, and even reverse engineering of extraterrestrial technology. However, none of those theories were based on any real evidence. But despite the absence of proof, many supporters of the UFO theory claimed that the Roswell debris was from a crashed alien craft. They accused the authorities of creating cover-up stories. This conspiracy narrative became a trope in movies, science fiction literature, and TV shows. No wonder that the town of Roswell is still promoting itself as the best destination for UFO-associated tourism. But what happened in this area in reality? The government's claim that a weather balloon had crashed at Roswell was indeed a lie. In 1994, the Air Force admitted that the recovered debris had actually been from an American balloon used to watch other nations. It was part of Project Mogul, an attempt to monitor anticipated nuclear tests that could be conducted by other countries. In 1997, an Air Force report called the Roswell Report, Case Closed, suggested that all those stories about alien bodies could have come from civilian witnesses who had seen parachute crash test dummies. The report also suggested that the witnesses might have combined several different events in their memories: the Project Mogul materials, the crash of test dummies, and a few other accidents that had occurred in the area. For many supporters of the UFO theory, though, those explanations sounded like the authorities planned to cover up their interaction with extraterrestrial civilizations. After all, in 1947, the USA, as well as some other nations, was in the midst of the flying saucer craze. People reported seeing bizarre objects in the sky. They claimed those were spacecraft piloted by aliens. It was against such a hectic background that a rancher discovered some highly unusual debris near Roswell, New Mexico. The material included tinfoil, sticks, and rubber strips. The next month, he took his findings to the Roswell sheriff. The man contacted the Roswell Army Airfield. After getting the wreckage, they issued that very extraordinary press release claiming that a flying disc had been found at a local ranch. The reasons for such an outrageous statement were unclear. In any case, the Roswell Daily Record picked up this press release right away, printing the story on the 8th of July with the headline, "RAAF captures flying saucer on ranch in Roswell region." That's when the military backtracked, announcing that it had been just a weather balloon carrying a radar target. That's a device that looks like a box kite made of foiled paper fastened to a balsa wood frame. The Roswell Morning Dispatch paid attention to this new claim and released a new story called "Army Debunks Roswell Flying Disc as World Simmers with Excitement."
Two pictures are rapidly changing in front of your eyes: our huge planet and a black void. The picture of Earth is getting smaller by the second. You're flying away from the spaceship into an endless vacuum and don't know what to do next. The International Space Station flies 250 miles above Earth's surface. A spacewalk is routine for astronauts who work there. Astronauts have spent more than 11,000 hours in the black abyss to this day. Fortunately, during all this time, no one has ever flown away into outer space without coming back, as we've seen in the movies. But unfortunately, astronauts face other, no less terrible, dangers during spacewalks. One such accident happened in 1966. Eugene Cernan put on a jetpack and went into outer space to carry out some repair work. The jetpack, which helps an astronaut control flight in zero gravity, heated up a lot. Eugene put on special protective pants made of metal to protect himself from this heat. The pants protection didn't work when he went into outer space. Instead of directing the heat away from his body, the pants began to heat up. The suit was heavy and uncomfortable, like a knight's armor. It rubbed his skin and restricted movement. Working in zero gravity is physically very hard, but Eugene also had to deal with his whole suit heating up that day. Inside the spacesuit, he felt like he was in a hot bath. High temperatures and hard work caused overexertion, dehydration, and severe weight loss. His face was sweating, and drops of sweat blinded him. During this spacewalk, the astronaut lost about 13 pounds of weight. Other astronauts came to the rescue and took him back to his spacecraft. To reduce overheating, they sprayed him with cold water from a hose. In a sense, to go out into an infinitely huge open space, an astronaut must put on a suit resembling a body cage. Another dangerous incident happened in 1973. Two astronauts, Pete Conrad and Joe Kerwin, went into outer space to repair a solar wing on the Skylab space station. The wing didn't turn around, and the astronauts tried moving it manually. Using force, they turned the stuck wing, but it pushed them. The push was so strong that it threw both astronauts aside. They didn't have time to grab onto a nearby surface and began to fly away into outer space. Fortunately, they had safety cables that didn't let the astronauts go away for good. By grasping them, the astronauts returned to safety. In an ordinary modern spacesuit, there are more than 10 protective layers. Such a suit protects against extreme cold and hot temperatures. It's tear-resistant and doesn't leak moisture from the outside. This protection is necessary to prevent depressurization. If a small passage appears between your body and space, then all the oxygen will start coming out of the spacesuit. The more oxygen the suit loses, the more vacuum it gets. This leads to terrible consequences, such as suffocation and increased body volume. It looks as if you start to inflate from the inside. In 2007, Rick Mastracchio went into outer space to do some repair work. For some reason, there was a hole in his left glove next to his thumb. It was on the outer layer of the glove. But the worst thing was that the astronaut hadn't noticed it. He continued to work as if nothing had happened. But one damaged layer could destroy the second. The second one could tear the third one, and so on, until the vacuum reached the astronaut's skin. Rick was supposed to work 6 hours in outer space, but during the 4th hour, he noticed the damage in his spacesuit. The astronaut reported this to command and received an urgent order to return to the ship. He never found out how the hole had appeared. Inside the ISS, there are many chemicals necessary for working in space. For example, ammonia has the property of freezing almost any surface. This chemical frost is used to cool some components of the station during overheating. The leakage of this substance on the ISS is practically impossible. This is exactly what astronaut Robert Curbeam heard from experts during the training before his first flight to space. But this accident occurred to him on his first spacewalk in 2001. Robert was working outside the space station when an ammonia leak started. The liquid splattered all over his spacesuit. A thick layer of ice quickly covered the glass. Robert didn't see anything. He feared that he had broken something, but the accident was not his fault. The protective layers of the spacesuit didn't allow Robert to freeze, but the ammonia severely restricted his movements. The main problem was that he couldn't return to the ship. Ammonia could get into the station, and this could lead to an emergency. Robert had to stand in outer space for 1.5 hours and wait for the leak to end. After that, he successfully returned to the station. To realize how difficult work is in outer space, we need to understand what a spacesuit is. It weighs 280 pounds, which is as much as a scooter. You won't feel its weight in zero gravity, but it will still make you sweat. Astronaut Chris Hadfield had described it by saying that every movement inside your spacesuit meets resistance. The suit scratches your skin, squeezes your bones and joints, and forces you to spend twice as much energy on simple movements. In such conditions, you start sweating and your eyes get wet. This moisture flies inside the helmet and blinds you until it evaporates. But if there's too much moisture, it can threaten the life of an astronaut. Such a case happened in 2013 with astronaut Luca Parmitano. He went into space to measure something outside the station. At one point, he felt that the back of his head was wet. He informed the others about it and got an order to return to the station. When Luca was coming back, he had to turn upside down. As soon as he did this, water gushed into his helmet. It covered most of his face. Luca couldn't see or hear. He tried to report the trouble to base, but the water covered his mouth. Fortunately, his partners rescued him and helped him return to the station. When they opened the helmet, almost half a gallon of water poured out. Astronauts' cables are some of the most reliable defenses against floating away into space. But what if one broke from a strong push, or because the astronaut didn't fix it well? For additional protection, there's a backpack called Safer, Simplified Aid for EVA Rescue. It's like a jetpack. It releases gas from small tubes and changes the direction of your flight. If you're spinning in space, Safer stops and aligns your movements. You can take manual control and fly using a special joystick. Safer was first used in 1994, but before engineers created it, there was the MMU, the Manned Maneuvering Unit. In 1984, astronaut Bruce McCandless used it for the first time. You may have seen this famous photo where he floats in outer space without a cable. The problem was that Bruce was the first tester of such a jetpack. He wasn't 100% sure if it would work. He went into outer space and unhooked the cable from himself. There was nothing else to keep him from flying into the infinite black abyss, and his team wouldn't be able to save him. Imagine how scary it must have been. Fortunately, the jetpack worked. However, after 3 missions, NASA decided to stop using the MMU as it was unsafe. After that, engineers invented Safer. Jetpacks and cables are reliable safety systems, but the best protection for an astronaut in space is their skills. Each astronaut has 6 years of higher education and several more years of training. They spend many hours training in virtual reality with spacewalk simulations. They train their body, endurance, and mind, since the main thing in a dangerous situation in space is not to panic and stay calm.
What can survive in space? Well, people can, if they have an excellent spacesuit. Spacesuits are, shall we say, kind of a needed item in the vacuum of space. Without one, you'll have to stay inside the spaceship or modular dwelling on the Moon or Mars. Currently, NASA has only several older spacesuits ready for use outside the spacecraft, like the International Space Station. NASA's Artemis mission to the Moon is planning to have new suits designed for both men and women. It has a $250 million budget for them. These new suits are much less bulky than the older ones and much more fashionable. But what other creatures besides people can live in space? 3 named animals were sent into space and they all came home safely. Does that qualify? 2 dogs, Belka and Strelka, spent a day inside a Russian spacecraft in 1960 and became media stars upon their return. The USA launched a chimp named Ham on a 16-minute ride into space. Space starts 62 miles above the ocean level and only takes a rocket a few minutes to get there. Ham, who wore a spacesuit, performed all his button-pushing tasks admirably and is honored in the International Space Hall of Fame in Alamogordo, New Mexico. But tardigrades can actually live in space. Tardigrades, or water bears as they are often called, are brown and look like teeny tiny grizzly bears, and are one of the most miniature animals with legs. They have 8 of them. Most species of tardigrades have no eyes, but some do. It's possible to see water bears with a good magnifying glass, since they average about a ½ millimeter in size. Sprinkle a little water on moss and they'll come out. They can walk about 1 body length per second and run at about 2 body lengths per second. Water bear eggs are easier to spot because they're bright white. The European Space Agency took water bears to the International Space Station and left them outside for 10 days. They survived. They still survived with no air, water, almost a perfect vacuum, harmful solar radiation, extreme cold, and heat. Well, that doesn't sound very fun, does it? In extreme conditions, water bears rely on their exoskeleton, or tun, to protect themselves. In laboratory tests, this exoskeleton could withstand immense pressure at over 87,000 pounds per square inch. That's quite a spacesuit they got. Water bears have even been frozen solid for 30 years, and when warmed up, the water bears revived and were still able to reproduce. As we search for life in space, as we explore Mars, these types of extreme life forms become essential to understand. If water bears can survive literally every environmental condition, can we conclude that life is everywhere in space? Extremophiles are life forms living in extreme conditions, such as other planets might have. Mobile Cave in the country of Romania is one such place that could just well be on another planet. All life on Earth, on the surface of the Earth, is carbon-based. It means that carbon atoms act much like a universal Lego block, to which hydrogen, oxygen, and nitrogen atoms connect to form the molecules that the cells of living organisms are made of. But not in Mobile Cave. Mobile Cave was sealed off at least 2.5 million years ago. The water that percolates up through limestone rock has formed a lake in the cave, a mix of hydrogen sulfide, poisonous and corrosive, and ammonia. What could live in this toxic soup? Well, sulfur-based life forms. An entire ecological system without light or photosynthesis exists inside Mobile Cave. The food chain is built on chemosynthesis, microorganisms eating sulfur-based chemicals. 33 species of sulfur-based creatures were found living in the hostile environment of Mobile Cave. Shrimp, scorpions, centipedes, snails, etc., etc. Mobile Cave is an alien world deep underground full of sulfur-based life forms. If creatures like this exist in Mobile Cave on Earth, what can we expect to find living in outer space? Bacteria. Bacteria can live in outer space, and fungi too. Bacteria form the base of the food chain, and bacteria have been proven to be able to live in outer space. In the 1980s, cosmonauts on the Mir space station complained that something was growing outside the station's windows and blocking their view of Earth. It turned out, upon inspection, to be bacteria and fungus, or fungi. The windows, made of quartz, were being damaged and weakened by what was growing on the surface. Fungi were also found to be eating copper on some of the cables. Mold was found growing in some places on the outside of Mir. The space station was under attack by microorganisms. Scientists took this very seriously and began to investigate. It seems that in a sterile environment such as space, bacteria come out of their hiding places when no other microorganisms are around. Cosmic radiation may even help them mutate and adapt to the space environment. The bacteria seem to be growing even faster in space than on Earth. Years later, the United States decided to run a bacterial experiment on the International Space Station. They coated rocks with various bacteria and put them outside the space station. Some bacteria did not survive the harsh conditions of space, but many did. One strain called OU-20 survived for over a year and a half outside the ISS. Japan also did a bacterial experiment on the International Space Station. Outside the Japanese Kibo module, Kibo's robotic arm placed 3 panels with the bacteria Deinococcus radiodurans, or D. radiodurans for short. It survived outside in space for 3 years. The lead scientists of the Japanese experiment calculated that the bacteria could live as long as 8 years in space. That's long enough to make a journey to Mars and back 4 times. Now, this raises a couple of interesting questions. Could life have come to Earth from Mars in a space rock? And, more pointedly, could an infectious bacteria come to Earth in a space rock? Suddenly, what had only been considered in science fiction books and movies was now a subject of intense scientific scrutiny. And then came the Mars meteor. Antarctica is the best place to find meteors because it's covered by ice. The ice in the Allen Hills regions of Antarctica is locked in place by the configuration of the surrounding mountain. The ice here sublimes. That means the ice evaporates, never becoming liquid, but turning directly into vapor. As the ice in the Allen Hills region sublimes, it exposes all the meteors that have hit the ice over many hundreds or thousands of years. Meteor hunters literally drive around on snowmobiles and pick them up with tongs, never touching them to avoid contaminating them with human bacteria. They bag the meteors, number them, and record the location and any other pertinent facts about the meteor. That's how meteor ALH 84001 was found, the Mars meteor. Since Earth gets hit by about 17 meteors every day, over thousands of years the numbers add up. Almost everywhere has been hit by a meteor at one time or another. 11 years apart, 2 houses on the same street in Weathersfield, Connecticut, had their roofs punctured by 1-pound meteors. But only a rare few meteors ever come from Mars. 126 meteors have now been identified as coming from the red planet. ALH 84001 came from Mars. Scientists know this because the United States has landed on Mars and sampled Martian rocks and the Martian atmosphere composition. ALH 84001 contained the same gases as Mars' atmosphere and similar chemical composition as the rocks. But the meteor also contained something else, a fossilized life form. There has been much debate about whether or not the tiny object inside ALH 84001 is a fossilized bacterial life form, or rather a chemical deposit. But the studies aboard the International Space Station confirm that bacteria can live for a long duration in space. So it is entirely possible that some bacteria could make the journey to Earth from Mars in a meteor. The United States Mars-exploring Perseverance rover has recently found organic molecules inside Mars rocks. These organics are carbon and hydrogen. It won't be known if these organic molecules were produced by living organisms or merely by chemical reactions until the samples are returned to Earth sometime before 2030. The search for life on Mars is ongoing. But Mars is not the only place in the solar system that might have life. Jupiter's moon, Europa, is a good suspect too. Entirely covered by miles of thick water ice, Europa may have an ocean of salty water beneath its icy crust. Ice acts as an insulation blanket. Combined with possible internal thermal processes in Europa's core, means that Europa's ocean water could be warm. The Europa Clipper Express mission plans to confirm conditions for life on Europa. Loaded with 9 pieces of observational equipment, the Europa Clipper will attempt to observe just about everything possibly going on by orbiting above Europa, including the chemical composition of the mysterious reddish-colored material that has ejected onto the surface ice from the ocean below. What could this reddish material be? Could it be a specific chemical mix? Or could it be krill, shrimp, fish, life forms like in Moville Cave? Or the ancient remnants of a Brightside narrator? Stay tuned. Space travel has come a long way since Sputnik was launched into orbit in 1957. Since then, we've sent humans to the moon, set up the International Space Station, and even sent robot spacecrafts to explore other planets. But there's still lots more to discover and achieve in space. So, what are our current plans? What technologies are we developing now? And what awaits humanity in the next 100 years? Let's find out, shall we? First of all, artificial intelligence. Fun fact, my high school history teacher claimed this is what I had as per my test scores. Right now, humanity is actively engaged in the development of artificial intelligence, and we've already made a bunch of breakthroughs in this area. With the help of AI, we're going to be able to explore the cosmos like never before. Think about it. AI can automate and optimize tasks like mission planning and data analysis. Now, human astronauts can focus on more important things, like looking for some non-human astronauts. Plus, AI can control and operate spacecraft remotely, reducing the need for risky human missions. And that's not all. This super smart technology can also provide unique perspectives and insights that humans might have missed. AI could also help us understand the data collected by space probes. In short, the use of AI in space exploration will help us learn more about the cosmos and make exploration more efficient and cost-effective. And this isn't the only thing that will help us in conquering space. Next, reusable rockets. Gone are the days of one-time use rockets. These days, reusable rockets are taking over the space industry. Not only do they save money, but they also make space travel more accessible to a wider range of people and organizations. To date, the SpaceX company has created a bunch of reusable rockets, like the Falcon 9 and Falcon Heavy. They've completed many successful missions to the International Space Station and beyond. Blue Origin has also made great progress in reusable rocket technology with the New Shepard. It's even planning to take paying customers on trips to space soon. Alright, so these cool technologies will help us get up there. But what are we going to do next? Moving on to building settlements beyond Earth. Space colonization, here we come. The possibility of establishing colonies on other planets, such as Mars, is a dream that has captivated humans for decades, and now it's finally within reach. But before we start packing our bags, here are a few obstacles we need to overcome. For starters, getting to Mars is no easy feat. It's a long journey that could take months, if not years. So first, we need to figure out how to keep humans alive and healthy during the trip. Now, once we get there, we'll face even more challenges. The harsh radiation and extreme temperature fluctuations are just a couple examples. Living and working in space isn't easy either. We need to make sure that everyone has what they need to survive. It's not like you can just go to the store for supplies. So we'll have to build systems to provide food and water, create some advanced transportation, and maintain all of that in good condition somehow. Finally, let's not forget about the most important thing: money. Building and maintaining a settlement beyond Earth is no small feat, and it will take a lot of resources and cooperation to make it happen. But there are still great benefits in living in space. It opens up many opportunities for scientific research and exploration. We'll be able to learn more about the universe and our place in it. So, no dream too big. Even though it's a big challenge, it has the potential to be really rewarding for humanity. That's why private companies and space agencies are already working on plans to send humans to Mars and potentially even terraform the planet. Actually, let's talk about that. Terraforming. The dream of turning a barren, inhospitable planet into a habitable paradise. Sounds like something straight out of a sci-fi novel, right? Well, believe it or not, by using advanced technology and resources, we could potentially turn deserts like Mars into beautiful Earth-like worlds. But here we also have a few hurdles to jump through first. Terraforming isn't exactly a quick process. It would take lots of time and resources to make any significant changes to a planet. There are also some ethical dilemmas to think about. If we start trying to change the Martian ecosystem, we could potentially wipe out any existing life forms. Imagine if someone did that to us. Actually, we've been doing it to ourselves. And finally, there's the cost. Terraforming would be a major expense, and it's not clear who would foot the bill. It would likely require the cooperation of multiple countries and organizations. But even with all these challenges, this is still an exciting prospect. Who knows? Maybe one day we'll be able to turn Mars into the ultimate vacation spot. And that's just the beginning, because we won't stop at Mars. Our next goal is asteroids and other celestial bodies. Now picture this: you're floating in your spacesuit, mining an asteroid for some seriously valuable resources. You strike gold, or rather a shiny vein of platinum, and head back to Earth to sell it for a fortune. And with the money, you fund even more space mining expeditions, becoming the ultimate space tycoon. But seriously, space mining could be a game changer for space exploration and the economy. Imagine being able to extract water from asteroids to sustain human settlements on other planets, or mining rare minerals to use in high-tech industries back on Earth. The economic benefits could be massive. Of course, there are also challenges to overcome. We'll need to figure out how to safely and sustainably extract resources from asteroids. We also need to make sure that space mining is done in an ethical and fair way. But once we deal with all this, it'll change our lives forever. So let's get to work. But once we've mined everything, what awaits us next? For example, what lies beyond our solar system? Interstellar travel and the search for life. We've already made some amazing discoveries in our hunt for extraterrestrial life. For example, NASA's Viking landers and the Galileo spacecraft have given us some clues about it. Also, in 2022, we found traces of organic matter in the former Martian lakes. We're not sure yet, but perhaps Mars was once as prosperous as Earth. But we all know that the real excitement lies beyond our solar system. Scientists have already found thousands of other distant exoplanets, and some of them are in their star's habitable zone, meaning they could potentially support life. So our next step is to send probes or even humans there. Imagine being the first person to set foot on another planet, discovering microbial life, or maybe even a more advanced civilization. Talk about out of this world. And maybe, one day, traveling to another star system will be like a regular road trip, except instead of a minivan, you're in a spaceship. And instead of stopping at a rest stop, you're stopping at a new planet. Sounds awesome, doesn't it? Right now, there are a few ideas about how we might make interstellar travel a reality. One possibility is the use of wormholes. These hypothetical tunnels in space-time could potentially allow us to travel vast distances in a shorter amount of time. It's like taking a shortcut, except instead of cutting through someone's backyard, you're cutting through the fabric of the universe. Pretty crazy, huh? Another option is antimatter propulsion. This involves using antimatter, which is the opposite charge of our regular matter, as fuel for a spacecraft. When it comes into contact with regular matter, it releases a huge amount of energy. Imagine your car's gas tank being filled with antimatter instead of gasoline. That's going to be a powerful ride for sure. Of course, there are still lots of challenges to overcome before we can make interstellar travel a reality. But let's hope that one day we'll all be able to pack our bags and hop on a spaceship for a trip to the stars. Anyway, the future of space travel is looking bright. With all of these advancements in technology, we're excited to see what feats of exploration the future holds. All aboard! This is the Intergalactic Cruiser. The destination on your ticket is a tour of the local group of galaxies, featuring the large and small Magellanic galaxies, the Orion Nebula, the Andromeda and Triangulum galaxies, and a few surprises in between. Tickets, please. Be advised you may experience a slight tingling sensation as we rev into hyperspace. The ship and everything in it is going through a dimensional phase change. It's nothing to worry about. The tingling passes quickly. Now, passengers, as we head toward galactic latitude 180 degrees north, as Terrarians are accustomed to calling it, our first main item of interest will be an intense star-forming region known as M42, the Orion Nebula. But first, a special treat by the captain that's not on the advertised itinerary. The Horsehead Nebula. It's off to the port side. That's left for you Aggies. Its designation is M43. The newborn star at the top of the Horse's Head has a strong solar wind that is deforming the shape of the nebular cloud. Get a good look at it now, because in a few thousand years, those gases will be completely blown away by the star-like nebula that made our sun. Yep, long gone, except for the nebular gases captured by Jupiter, Saturn, Uranus, and Neptune. Okay now, one of our junior explorers asks a question. What is the M in M42 and M43? Well, young lady, the M stands for Messier. Pronounced Messier, not Messier, as in, is your room messier than mine? Charles Messier to be precise, was a French astronomer in the 18th century. He published a catalog of 110 fuzzy objects as seen through an early telescope. The Horsehead Nebula is number 43 on his list. We'll see more M's as we continue our tour. Heads up, we're coming to the Orion Nebula. The gases in the nebula may seem less colorful than you expect. That's because we're accustomed to seeing long-exposure telescopic photos and enhanced photos designed to highlight the different gases in the nebula. May I suggest using the pair of tinted glasses that come with your onboarding packet if you want to heighten your experience. In we go! Now, it's a good thing we are in hyperspace. As we approach the trapezium star cluster in the center, the bright star, Theta C, sends out a solar wind at 5 million miles an hour. It sculpts the whole cloud of gas and dust, creating shock waves that compress nearby stars. Theta C is a megastar, 200,000 times brighter than the Sun. It will go supernova in about 1 million years. I won't be around then. Oxygen, hydrogen, and sulfur glow in ionized states like a fluorescent light bulb. Oxygen blue, hydrogen red, some green and sulfur, and dust glow as yellow-orange. As we pull out of the Orion Nebula and rise high above the galactic plane, the spiral arms of the Milky Way are visible. Our sun, which you cannot distinguish from this height above the galaxy, is in the Orion spur that lies between the outer Perseus arm and the inner Sagittarius arm. Notice the center of the Milky Way contains a bright magnetic bar that plays an essential part in star formation. Over 70% of nearby galaxies include magnetic bars. It's a sign of a mature galaxy. Only 20% of distant galaxies contain magnetic bars in their cores. Which reminds me, passengers, the juice bar is now open. Our H1 server will take your orders. Now, that's the Andromeda Galaxy far, far out to the port side. But may I call your attention to the many dwarf galaxies, over 40 of them, that populate our galactic neighborhood. We're heading to one now. The Large Magellanic Cloud, LMC to astronomers, is an irregular dwarf satellite galaxy of the Milky Way, containing about 30 billion stars with a dynamic star-forming region called the Tarantula Nebula, which we will be cruising through shortly. Of course, if there is a large Magellanic Cloud, there must be a small Magellanic Cloud, SMC. And there it is, below and to the left of the LMC. The Milky Way will eventually ingest both dwarf galaxies. Some prefer the word accreted, but the result is the same. If you use your tinted glasses again, you can see that the LMC has stripped away a tremendous amount of gas from the SMC, as they have interacted gravitationally over millions of years. Hey, I know all about gas. Now we're heading out of the Milky Way to a distance of about 50 kiloparsecs. That's 50,000 parsecs, or about 163,000 light years. So, what's a parsec? No, it's not slang for pair of socks. A parsec is about 3.26 light years. A light year is about 5.88 trillion miles. The word parsec is a combination of two words, parallax and second. Parallax is the shift an object seems to make when viewed from two different perspectives. Looking at an object with your left eye and then your right eye, you'll see the object appear to shift. That's parallax. When an astronomical object is photographed with the Earth on one side of the Sun, and then again 6 months later on the other side of the Sun, the shift is measurable in degrees of arc, or minutes of arc, or seconds of arc, down to milliseconds of arc. That's a parsec, a parallax of 1 arc second, which turns out to be 3.26 light years. Hey, what about a Joan of Arc? That's how you measure distances in France. Ha ha! Meanwhile, since you can't measure a light year with a ruler or a tape measure, parsecs are the scientific way of telling the distance to a star or intergalactic object. The greater the parallax, the closer the object is. The smaller the parallax, the farther away it is. Now, straight ahead in the heart of the Tarantula Nebula is the R136 star cluster. Within a distance of 1 light year, there are over 40 stars each with a mass over 50 times that of the Sun. Wow! Comparatively, there isn't a single other star within 4 light years of our home star, Sol, and that's a good thing. You can see supernova 1987A at about 2 o'clock high. A blue giant star, 100,000 times brighter than the Sun, experienced a core implosion, resulting in a Type II supernova 100 million times brighter than the Sun. It has left behind a neutron star, clouded in dust and gas, and a wildly spectacular display of fireworks. Now, 1987A in the Large Magellanic Cloud is the closest supernova to Earth since 1604, which happened in the Milky Way about 20,000 light years from Earth. It was visible in the daytime for about 2 weeks, or so. After 1987A went supernova because it was a blue giant star, speculation has increased that the blue giant star Rigel, the foot star of the constellation Orion, might go supernova in the not-too-distant future, or already has gone supernova. Rigel is approximately 860 light-years from Earth, so anything that happens to Rigel would take about 860 years before it would be noticed on Earth. Supernova 1987A ejected the heavy elements like cobalt, nickel, and iron and lighter silicates into the Tarantula Nebula, where they will form the basic building blocks of stars and planets. Our server is now offering space-themed snacks. May I recommend the Jupiter Cotton Candy Puffs for the children on board? Remember, I know all about gas. Our next stop is the Andromeda Galaxy and environs. Notice its halo as we leave the Milky Way and its 300 billion stars behind. As many as 150 globular clusters reside in the galactic halo. They orbit down and through the galactic disk and contain some of the oldest stars in the universe. How they got here in our home galaxy is a matter of intense study. You will notice NGC 6822, an irregular dwarf galaxy off to the starboard. NGC stands for New General Catalog of Astronomical Objects. Now you'd think there'd have been an old general catalog, but there wasn't. It was just a new catalog. There is, however, a revised new general catalog which astronomers refer to regularly. Clears that up, huh? As we pass NGC 6822, you'll notice a magnetic bar beginning to form and bright patches of new star formation. This galaxy was discovered in 1884 by E. Barnard and is also called Barnard's Galaxy. Mr. Barnard was quite an astronomical observer. He has a crater on the moon named for him, one on Mars, an area on Jupiter's moon Ganymede, a minor planet, number 819 Bernardiana, and the star with the fastest movement across the sky, Bernard's Star. Now, not too many people have their name emblazoned across space, as has Edward Emerson Bernard. Approaching the giant Andromeda Galaxy with its trillion stars, we will skirt above its western edge and visit one of the enormous galaxy's dwarf companion galaxies, M110 or NGC 205. Yes, it also has two designations. Hey, take your pick. The first of its kind, a dwarf spheroidal galaxy of about 3.5 billion solar masses, M110 or NGC 205 if you wish, has 8 globular clusters near its core. It too will be swallowed, or accreted if you prefer, by the Andromeda Galaxy. It may have already been stripped of much of its stars and gas, a point highlighted by M110's general lack of star formation. Everybody having fun yet? And now, our final stop, M33, the Triangulum Galaxy, the third and last spiral galaxy of our local group. Located in the small constellation of Triangulum, Latin for triangle, good guess, M33 is about half the size of the Milky Way. The Triangulum Galaxy is 2.7 million light-years from Earth, but it is much closer to the Andromeda Galaxy and moving towards it. If two spiral galaxies collide, it may alter the course of the Andromeda Galaxy and prevent the predicted collision with the Milky Way. Well, let's hope so. Now, this important message. We will serve dinner on our return trip to Earth. There's a choice of chicken or fish. We hope you have enjoyed the tour. Hey, if you fill out our survey and give us 5 stars, you can also have dessert. Are we really by ourselves in the universe? It's a daunting question that's been haunting us for centuries. No wonder scientists have tried to come up with all sorts of ideas as to why. One of the strangest theories concerning our lack of contact with other life forms is named the dark forest theory. Let's start small. Well, sort of. We'll focus on our Milky Way for now to better understand this theory. Our cosmic neighborhood is a galactic wonderland, sprinkled with 200 billion twinkling stars and maybe around 100 billion planets. So let's get hypothetical for a moment and say a tiny part of those habitats hosts life. Further, out of those life-bearing planets, a few might have evolved into intelligent beings. Given that, you'd think we'd be knee-deep in weird-looking neighbors, some of whom might be actively trying to find us or might just be out there, waiting to be discovered. Now, let's put a little science into this science fiction scenario. We have something called the Drake equation. which is a kind of universal roll call that estimates how many smart civilizations could pop up in our galaxy. You can think of this equation as the super smart roadmap. By playing around with a few important factors, the equation hints that there should be around 20 civilizations just in our galactic backyard. So why haven't we stumbled upon any yet? This theory isn't an easy task. It's a mixed bag of multiple variables, like the average number of planets per solar system that could potentially host life, or the rate at which stars suitable for intelligent life are formed. A tricky part here is that astronomers have yet to solidify the exact values of these variables, which means our calculations are just approximations for now. But back to the Milky Way, shall we? Feed in our hypothetical assumptions, crunch the numbers, and you get at least 20 civilizations. Yet somehow, our cosmic switchboard remains weirdly silent. How come? This radio silence has its own name too, the Fermi paradox, named after the guy who first thought, "Hey, where is everybody?" over 50 years ago. Since then, we've had a lot of different theories trying to solve this mystery, all tinkering with different aspects of the Drake equation. Some folks think the appearance of life is a rare event. Others think that getting from bacteria to advanced beings is the tricky part. Yet, some reckon that civilizations might either wipe themselves out after a short lifespan or never even get to invent something they could communicate with. But there's one theory that tops all others in its creepiness: the dark forest theory. According to it, the universe is a huge cosmic version of a haunted forest. And other types of creatures are out there, playing a game of hide and seek. They're intentionally keeping silent. Why? Well, the dark forest theory was best explained in a sci-fi novel, and the rationale goes something like this. For starters, every life form wants to stay alive. I'll buy that. If we go with that assumption, it's impossible to be sure whether other life forms might harm you if they get the chance. So, the safest bet is to take them out before they find the right time to do the same to you. Frankly speaking, it's the universe's version of the survival of the fittest. In this scenario, making contact with others becomes the most dangerous game, as it could lead to your location being traced and you being wiped out. How human. This results in everyone keeping quiet, a kind of universal shush, where every civilization tries to hide in utter cosmic silence. But hey, is this just an idea good for a thrilling novel, or does it have some real-world implications? Well, the theory was suggested by scientist David Brin as a possible explanation for the lack of radio evidence for non-Earth-like life. He went as far as imagining it would be robots that would do the dirty work of wiping out civilizations. But how realistic is this theory anyway? Well, it doesn't require us to assume a lot of stuff about the behavior of all foreign civilizations. Just one advanced race behaving this way could explain our observed reality. And it might explain why we've not picked up any advanced radio chatter despite a century of eavesdropping. It's possible that other creatures like us are too terrified of being noticed and have gone radio silent on purpose. But, and it's a big but, like mine, it does base itself on the notion that other species share our level of risk aversion and logic, or that there's a rogue civilization out there, picking off anyone they perceive as a threat. And that's a pretty significant assumption. If that doesn't sound creepy, this next piece of information certainly will. For about a century now, we've been shouting our existence into the cosmos. If this theory proves to be correct, every other civilization within 100 light-years of us might be getting our signals and knowing exactly where we are. And if we have reasons to hide from them, as suggested by some like Stephen Hawking, we might already be in trouble. But what if this theory isn't true? What if, sooner than we'd like to imagine, weird galactic creatures will indeed try to reach us? The truth is, most of us wouldn't even know what to do. Hey, let's not get over ourselves. In fact, some scientists are tackling this issue head-on. For the first time since the 1980s, specialists are trying to cook up a how-to guide for when we inevitably bump into cosmic neighbors. For instance, some researchers believe we've got to do more than just worry about how these life forms could shake up our world. If they send any type of radio signals down here, we've got to think about our reply. What are we going to say? Hey, we're humans. Nice to meet you. Absolutely not. We've got to do better than that. See, the only plan we've had till now came from a rough blueprint dating from 1989. This guide is a bit wishy-washy on what to do when the entire world gets the outer worldly text. Mostly it says, hey, let's share the news with everyone. But then what? If we confirm it's legit, officials will need to ask the United Nations for advice. But hey, does the United Nations even have a plan? Maybe, who knows? We've been doing loads of space exploring lately. Some say we've stumbled upon water on Mars. Others are sure we've spotted some planets that could be twins to Earth. So, the idea of finding life elsewhere isn't that far-fetched. But even after 100 years of trying to chat with cosmic beings, it's still a one-sided conversation. This new protocol isn't just about chatting up outsiders. It's also going to act as our cosmic voicemail, checking messages from outer space. It aims not just to decode the external lingo. It's also planning to figure out what these messages could mean for us. The plan is also to draft reports about how different policies could impact us and set up guidelines on how to respond to these space texts. So, will we ever get a message from our cosmic mates? Only time will tell. But what we do know is that we just can't wing it. We can't be caught off guard and start a planet-wide frenzy when we get that otherworldly WhatsApp. We gotta have a plan, and we gotta have it ready for when we're face-to-face with the real deal. I mean, we've come across a lot of potential such sightings, but none of them proved to be genuine. On that note, U.S. authorities checked over 100 cases of weird stuff going on in the skies. I'll spare you the details, but not one green creature was ever found. More like drones and similar stuff floating around. So, as we stand on the cusp of this potentially game-changing event, we must strive to be prepared. Whether our intergalactic neighbors drop us a text tomorrow or centuries from now, we need a plan. After all, this could change everything we know about our universe and our place within it.
Earth's magnetic field hides a fascinating story. It turns out that it's getting weaker day by day. In fact, it's been doing so for the last 3,000 years. And if this trend continues, we could be in for some trouble within a millennium. What's the big deal? Well, picture this. Magnetic north becomes south, and vice versa. Pretty wild, right? When this happens, our planet's protective magnetic shield might weaken, allowing more cosmic rays to hit us. These high-energy particles from the universe can cause electronic malfunctions in our satellites and produce elements that could be harmful to us. The last time a polarity reversal occurred was between 772,000 and 774,000 years ago. Thankfully, humanity has some pretty smart people on the case who are investigating the history of Earth's magnetic field. They take cores of sediments from the seafloor and study the magnetization of fossils to figure out when these reversals occurred in the past and when they might happen again. Another group of researchers is studying the South Atlantic Anomaly, SAA, a vast region of Earth's magnetic field that is about 3 times weaker than the field at the poles. Using data from multiple satellites, they are trying to figure out what's causing the SAA and how it might change in the future. This could give us a glimpse into how a weakened magnetic field can affect our satellites and our planet. Sure, our generation won't be here to witness these changes, but it does make you wonder what that planet might look like upside down. Magnetically, that is. NASA's astronomers have also announced that in 4 billion years, the Milky Way galaxy is going to get a major glow-up. After a cosmic collision that will shake things up, I'm not talking about a small fender bender here. I'm talking about a titanic collision with our neighboring Andromeda galaxy. Humanity will have to hold on to its space helmet for this one, because the sun might get flung into a new region of the galaxy. However, our Earth and solar system probably won't be seriously affected. Sounds difficult to believe, so how come? NASA's Hubble Space Telescope did some hardcore measurements of Andromeda's motion. Although the galaxies will plow into each other, the stars inside each galaxy are so far apart that they won't collide with other stars during the encounter. However, the stars will be thrown into different orbits around their new galactic centers. According to simulations, our solar system will probably be tossed much farther from the galactic core than it is today. Set your telescopes aside. You don't need to start counting down the years. This event is likely scheduled in about 4 billion years, so chances for us to witness it are 0. Saturn is losing its rings. Thankfully, we won't be here to witness this sad event either. Apparently, the rings are being pulled into Saturn as a dusty rain of ice particles, all under the influence of Saturn's magnetic field. According to NASA's research, the ring rain is draining an amount of water products that could fill an Olympic-sized swimming pool from Saturn's rings every half an hour. The entire ring system will likely be gone in 300 million years. Scientists believe we should consider ourselves lucky to witness Saturn's ring system at all, as it seems to be in the middle of its lifetime. But if you think about it that way, that rings around planets are all temporary, there's a chance we've just missed out on the giant ring system of Jupiter, or those of Uranus and Neptune. These planets have only thin ringlets around them these days. Scientists have long debated whether Saturn was formed together with its rings or if the planet acquired them later in life. The new research favors the second scenario, indicating that they are unlikely to be older than 100 million years, while Saturn itself is around 4.5 billion years old. What caused the rings to appear in the first place? Well, there are a few theories. One of them suggests the rings could have formed when small, icy moons in orbit around Saturn collided. Perhaps their own orbits were messed up by a gravitational tug from a passing asteroid or comet. Who knows what humans might end up looking like in the future? It's unlikely we'll see any major changes in our lifetime. But let's take a journey to the future and ponder what we might evolve into. Will we become cyborgs with all sorts of cool machine implants? Or maybe we'll become a hybrid species of biological and artificial beings. To understand our future evolution, we gotta take a peek at our past. 1 million years ago, Homo sapiens didn't even exist. There were a few other similar species though, like the Neanderthal. Fast forward to today, and humans have become taller and sturdier. Maybe in the future we'll become smaller to conserve energy, as it's predicted that our planet will get more crowded. Speaking of crowded planets, living in these new conditions means we have to adapt, and fast. We're constantly interacting with lots of people, and remembering names is becoming a crucial skill. Luckily, technology might help us out with brain implants that will improve our memory. In the future, we might also have more noticeable technologies as part of our appearance. Imagine having an artificial eye with a camera that can read different frequencies of light. While predicting 1 million years into the future is pure speculation, we can use bioinformatics to make some predictions about the immediate future. Demographic trends suggest that urban areas will become more genetically diverse, while rural areas will become less diverse. And what about space? If we end up colonizing Mars, our bodies could change due to lower gravity. Maybe we'll have longer arms and legs, or even insulating body hair like our Neanderthal cousins. In the future, our moon is also going to witness some dramatic changes. We'll miss these ones too. In about 5 billion years, things are going to get really interesting in this corner of the universe. For now, the sun is chilling in its main sequence phase, just burning hydrogen like nobody's business. In the future, during the red giant phase, the sun is gonna puff up like a balloon until its atmosphere reaches out and engulfs our beloved Earth and Moon. Our natural satellite, which is already moving away from Earth, is gonna get warped around the sun's influence. Its orbit will get all wonky, and it'll end up closer to Earth during the new moon phase than during the full moon. And that's not even the worst part. If left alone, the moon would keep on moving away from Earth until it'll need almost 50 days to orbit us. As the sun continues with its own journey, its atmosphere will drag on the moon and cause its orbit to decay. Eventually, the moon will get torn apart into a stunning ring of debris circling Earth. We're talking about all its mountains, craters, and even the footprints and flags we left there, all scattered throughout the debris field. There's a chance the sun will shed enough mass to spare Earth and the moon from total annihilation. Or if we're really lucky, the sun will lose 20% of its mass and we'll be safe and sound. It's all just theory right now. We haven't seen a red giant star during this phase. The universe itself might go completely dark one day too. Scientists can't predict it with absolute certainty, but they can make some educated guesses. Right now, our universe is 13.77 billion years old, and it's still churning out new stars left and right. It's said that eventually, after about 1 trillion years, the last star will be born. That final star will be a little guy, a red dwarf, just a fraction the size of our sun. These stars are champs at living long lives, slowly sipping on hydrogen to keep their fusion reactions going. But even they can't last forever. Fast forward about 100 trillion years, and the last light will go out. The universe will be dark and lonely, but thankfully, we won't be here to watch it all fade away. Chances are, we're going to find life beyond Earth by 2035, and there's no need to travel to a galaxy far, far away. Our Milky Way galaxy is full of totally suitable environments. Don't get too hyped up though. We're talking about microbes or chemical markers, not Hollywood-like green humanoids. Even so, when we finally find traces of life, it will change how we see our place in the universe. NASA's Kepler Space Telescope discovered something incredible. Almost every star has planets, and many of these planets might be habitable. Rocky planets like Earth and Mars are even more common in our galaxy than gas giants like Saturn and Jupiter. Also, we already know that our galaxy is very rich in water. There's water in interstellar clouds where stars and planets form, in the debris disks around other stars, in comets, just everywhere. What's really hard though is finding life itself. Ideally, to finally find it, we need to land on every single planet out there and literally check under each rock. But thanks to the newest research, we can at least narrow down the search to potentially habitable worlds. The James Webb Space Telescope, a super powerful telescope that was launched into space in 2021, is onto this. It checks the atmospheres of nearby super-Earths, rocky planets that are a bit bigger than Earth. It searches for life-related gases, chemicals that can only be produced by living things. And they already found some clues. For example, they detected signs of such a chemical on a planet called K2-18b. This planet is 120 light-years away, which is pretty close on a space scale. This planet is in the Goldilocks zone, which means a zone around the star where the temperatures are just right for liquid water to exist. It orbits a red dwarf star, the smallest type of star there is. Such stars are a bit fainter than our sun. It will take about a year to check if these hints of life are real. If so, it would mean that life is much more common than we previously thought. But even if it's not, there are 10 more Goldilocks planets on their list to study. The James Webb Space Telescope is a very cool tool, but it has limits. It can't detect small Earth-like planets due to their size. To fix this, NASA plans to launch another tool, the Wide Field Infrared Survey Telescope. This one will be even better at spotting such planets and life-related chemicals. And also, we have the SETI project. SETI stands for Search for Extraterrestrial Intelligence. This project has been on a hunt for extraterrestrial creatures since the 1980s. They also believe that we'll find signs of life within the next 10 years. Not so long ago, they started a super big and cool project. It's called COSMIC, and it uses an array of radio telescopes in New Mexico. You might have seen those in the movie Contact. COSMIC allows scientists to listen to hundreds of thousands and potentially millions of star systems at the same time. If there are any interesting signals, scientists can check them right away, instead of waiting for weeks or even months. The signals themselves are often very sudden and short, but COSMIC can detect even the shortest ones that last nanoseconds. COSMIC can also help with other research, like studying mysterious and unexplained fast radio bursts, or even dark matter. This is the biggest and most powerful tool for searching for extraterrestrial life we've ever created. But it's not enough to just listen. Why don't we reach out ourselves? NASA has sent some signals into deep space. In 2002, their Deep Space Network sent a signal to the Pioneer 10 satellite. But there was an obstacle in the path: a white dwarf star 27 light-years away from Earth. If there's a planet around this star, perhaps the signal reached them too. If there are any intelligent species there, we could receive a reply by 2029. The DSN keeps sending powerful transmissions into space. These signals will bump into 222 stars within the next 3 centuries. Maybe someday we'll receive a reply from somewhere far away. But why haven't we received a response yet? There are about 200 billion galaxies in the universe, each with around 100 billion stars. If just 1% of those stars had one planet, that's still 200 quintillion possible planets. And we can narrow it down even further. If the chance of them having life is 1 in a trillion, that would still leave us a few 100,000 planets. So, where is everyone? This is a famous question known as the Fermi paradox. The first possibility isn't that terrifying. It's possible that the universe is full of life, but this life isn't intelligent in our traditional sense. Some planets might have microbes, birds, or space dinosaurs. This is called the Great Filter Theory. It suggests that there are certain filters that life has to overcome in order to become intelligent, and maybe other species just haven't overcome them yet. Think about it. Life on Earth started in the ocean, then crawled onto land, diversified into many forms, went extinct in massive events 5 times, evolved again, and eventually led to humans. We built societies, developed healthcare, and only then started searching for another life. There's another idea called the Gaian bottleneck hypothesis, which suggests basically the same thing. While it might not be too hard for basic life to start, it's incredibly tough for that life to survive and thrive over long periods. Venus might have had oceans and Earth-like conditions too, but something went wrong. Its oceans boiled away because of a runaway greenhouse effect. Now it's sterile. Mars also had liquid water on its surface once, and both the Moon and Mercury had thick atmospheres for a short time. Meanwhile, Earth has had liquid water on its surface for almost its entire existence. It's super rare and remarkable for a planet to hold temperatures from 32 to 212 degrees Fahrenheit for millions of years. So, maybe it's a mistake to look for intelligent life, especially the one that uses the same technology as we do. It evolved under completely different conditions after all. That's also where the so-called Drake equation comes in. It's a formula that gives us a chance to calculate the potential of life becoming intelligent on a planet. To calculate the result, we need to know several variables: how many stars there are, how many of them have planets, the chance of these planets having life, and so on. Unfortunately, we don't know these numbers yet, and the result might be insignificant. But let's assume that there is at least one other intelligent species. Why haven't we met yet? There might be many reasons. Maybe they don't think we're interesting enough, or maybe the problem is with us. Perhaps we keep missing their signals, or maybe we miss the entire species itself. The universe is insanely huge and ancient. It's over 14 billion years old. If we compress Earth's entire evolutionary history into a 24-hour day, life starts at 4 a.m. Dinosaurs go extinct at 11:40 p.m. Human-like creatures appear 2 minutes before midnight. In this analogy, humans have existed for just 77 seconds, and our technology capable of detecting extraterrestrial life is even newer, less than a second. With such vast distances and time spans, the chances of us existing at the same time as other civilizations are slim. If their civilization lasted only a few millennia, we could easily miss them entirely. But that doesn't mean we should give up our search. Scientists were worried that Earth's radio signals had dimmed over time. But a recent study showed that it's actually the opposite. The numbers of our satellites keeps growing, and this makes our planet more detectable. By the end of the decade, we could have 100,000 satellites, making Earth incredibly bright in the radio spectrum. If there is an advanced civilization out there, they will easily spot us even from very far distances. Astronomers are super optimistic about it. There is a high chance they'll find extraterrestrial creatures while you and I are still around.
There are probably 36 other civilizations hanging out in the Milky Way, and over 170 billion galaxies, give or take, in the observable universe. Conditions for life are all over space. So, where is everybody? Nuclear physicist Enrico Fermi came up with this exact same question during a lunch break with his colleagues in 1950, leading to one of the most unsettling paradoxes in the universe. Even though there's a huge probability of extraterrestrial civilizations existing, we still haven't found any clear evidence of them. One possible explanation comes from the zoo hypothesis. It suggests that advanced extraterrestrial societies exist and know exactly who we are and where we are, but intentionally choose to stay hidden. They're just observing human quirky behaviors, as if we're in some kind of a cosmic wildlife park. But their intentions could be much darker. If you're a Star Trek fan, you probably remember the main rule for Federation members. Starfleet officers shouldn't contact species that are not advanced to avoid messing with their development, even if it means risking their own lives. Now, even though it's fiction, this rule perfectly captures what the zoo hypothesis is all about. Beings from other corners of the universe see our planet as a cosmic zoo with one-way bars. They can watch us brushing our teeth in the morning or walking our dog, but we can't catch a glimpse of them. In this theory, non-terrestrial life forms deliberately keep their distance from us, sticking to a hands-off policy agreement in the vast cosmic neighborhood. It's like those super smart beings agreed that we needed to have the freedom to shape our own future and destiny, following our own path of development without external contamination. The idea is that these super advanced civilizations could be like, 500 million years ahead of us, which would explain why we haven't seen any signs of them. And maybe it's better this way, as humans could eventually be destroyed or even assimilated by this new cosmic power, Independence Day style. As much as things like going to an art museum might be interesting to us, extraterrestrials probably wouldn't be too thrilled watching us stare at the Mona Lisa painting for hours. Interplanetary cultures might be more into buying tickets to quietly observe how we're developing new technologies, such as ultra-modern satellites. According to the zoo theory, they can't reach out to us until we hit a certain level of development, so improving our technology and wisdom could be the only way to show them that we're mature enough and don't need their spaceship parenting anymore. There are a couple of reasons why it's hard to buy into the zoo hypothesis. Extraterrestrials might not visit or reach out because we're not all that advanced. But it is tough to explain why they keep ignoring all our attempts to communicate. even if the zookeepers try their best not to interfere with animals' lives and behaviors. I bet they couldn't just ignore a bear speaking in loud and clear English about its desire to communicate. So that's pretty much why humans keep trying and trying to provoke some reaction from inhabitants of other planets using radio signals. In 2017, in a valley 8 miles southeast of the Norwegian city of Tromsø, a radar antenna transmitted some specially composed electronic music to potential intergalactic listeners. The target audience was in GJ273, also known as Lytton Star. It's a runty red dwarf located 12 light-years from our solar system. Since radio waves travel at the speed of light, we'll have to wait more than 2 decades before looking for a reply. But the main problem with radio waves is that we're kind of in the dark about where to look, and civilizations might be as far as 17,000 light-years away. Plus, we don't know which radio frequency extraterrestrials use to chat. Now here on Earth, we use the radio spectrum to send signals into the universe, assuming that what works for us might be a common method for other civilizations. But in fact, it could be considered a somewhat old-school technique for other beings. That's why current projects are now looking for technosignatures, which are signs of technological activity from extraterrestrials, like city lights, solar panels, megastructures, or artificial satellites. Another potential clue is to study the atmospheres of planets orbiting nearby stars, as an advanced civilization might be altering its atmosphere with different gases, making it detectable. Despite decades of observations, there is still no definitive evidence that advanced extraterrestrial civilizations are out there. But that doesn't mean they don't exist. Even by expanding search fields, we're talking about odds much slimmer than hitting the jackpot, with a roughly 1 in 3 billion chance of finding an advanced civilization within a given distance from Earth. Maybe space creatures are responding to our communication attempts, but in a way that we can't understand. The universe has been around for more than 13 billion years, while humans showed up just 200,000 years ago. And this is about 0.01% of the universe's age. It's like we're still learning to talk, while other super smart beings might be sending us messages that are all lost in translation. We keep waiting for a giant UFO to land on Earth and for green ETs with huge eyes to come out of it. But we forget that our intergalactic neighbors could be more interesting in building nanotechnologies to watch over us. They could also be trying to communicate using neutrinos, which are subatomic particles with an extremely small mass that could effortlessly pass through our planet without being detected by our current technological devices. Now, the zoo hypothesis has another issue. It is pretty tough to believe that, with all these civilizations supposedly hanging out in the universe, they would all decide not to reach out to humans. For this to happen, there would have to be a great sense of structure, with a higher intelligence working as the head of the universe, giving them direct orders and clear rules to keep us isolated. But we're talking about billions of possibilities for life, right? More civilizations mean that there are more chances of a violation of this no-contact rule. So, most likely, at least one independent planet would be just as desperate to find life in the universe as we are. Some scientists also believe that if such advanced life had substantially colonized Earth and many other planets, we would know it by now. The zoo hypothesis has 2 other variations that are even more frightening. In the laboratory hypothesis, nobody contacts us because humankind is actually being subjected to experiments, and Earth is essentially a giant science lab. Otherworldly creatures could be analyzing human responses to various survival challenges, such as tsunamis or massive earthquakes. In this case, the no-contact agreement between all other space groups would make a bit more sense, since it's in the name of scientific research for the greater good, at least for them. The planetarium hypothesis, proposed in 2001, suggests that we are living in an artificial universe, in some kind of virtual reality, designed to give us the illusion that the universe is empty when it's not. But no possible generator could test this hypothesis. Besides the zoo, the laboratory, and the planetarium theories, there is another possible answer to the Fermi paradox. Nobody contacts us because humans are completely alone in the universe. This is known as the rare Earth hypothesis, and it emphasizes how Earth occupies an incredibly unique position. No other planet could bring life to the universe that could be more than just bacteria. We may consider ourselves pretty lucky, as even a small change in any of Earth's orbital parameters, like the distance from the Earth to the Sun or the rate of rotation, could make conditions too extreme for people or life in general. But again, it's hard to think that we are alone in this vast universe. So, we're back to the paradox. Where is everybody? Our Sun is an average-sized star, and still, it could fit 1,300,000 Earths. The star is also 333,000 times as heavy as our planet. NASA has translated radio waves created by planets' atmospheres into audible sounds. That's how astronomers found out that Neptune sounds like ocean waves, Jupiter like being underwater, and Saturn's voice resembles background music to a horror movie. Here on Earth, it's bebop jazz. No, I made that up. The sun's surface is scorching hot, but a bolt of lightning is 5 times hotter. Earth gets struck by 100 lightning bolts every second, which results in 8 million lightning strikes a day and around 3 billion a year. Ooh, shocking. If you manage to go to the moon one day and see fresh footprints, that doesn't mean there's someone else there with you. Footprints or similar marks can last for 1 million years over there. Because the moon doesn't have an atmosphere. There are no winds, not even a breeze, that can slowly erase those footprints. Astronomers have found the largest hole we've ever seen in the universe. It's the giant void that spreads 1 billion light-years across. They found it accidentally. One of the research team members was a little bored and wanted to check how things are going in the direction of the cold spot. That's an anomaly in the Cosmic Microwave Background Map, or CMB for short. It's a faint glow of light that falls on our planet from different directions and fills the universe. It's been streaming through space for almost 14 billion years as the afterglow that occurred after the Big Bang. So, you fall right into the heart of the black hole and prepare for a sad end. Well, you don't have to. Falling into a black hole won't necessarily destroy you or your spaceship. You have to choose a bigger black hole to survive. If you fall into a small black hole, its event horizon is too narrow, and the gravity increases every inch down. So, if you extend your arm forward, the gravity on your fingers is much stronger than on your elbow. This will make your hand lengthen, and you'll feel some discomfort. Rather significant, to be honest. Things change if you fall into a supermassive black hole, like the ones in the center of galaxies. They can be millions of times heavier than the Sun. Their event horizon is wide, and the gravity doesn't change as quickly. So, the force you'll feel at your heels and at the top of your head will be about the same. And you can go all the way to the heart of the black hole. This myth is busted. If you watch a very touching movie in space and start crying, your tears won't run down. They will gather around the eyeballs. Your eyes will get too dry, so you'll feel like they're burning. Any exposed liquid on your body will vaporize, including the surfaces of your tongue. Speaking of burning, that's one thing fire can't do in space. Fire can spread when there's a flow of oxygen, and since there's not any in space, well. Once they explode, stars aren't supposed to come back to life. But some of the stars somehow has survived the great supernova explosion. Such zombie stars are pretty rare. Scientists found a really big one called LP 40-365. It's a partially burnt white dwarf. A white dwarf is a star that burned up all of the hydrogen, and that hydrogen was previously its nuclear fuel. In this case, the final explosion was maybe weaker than it usually is, not powerful enough to destroy the entire star. It's like a star wanted to explode but didn't make it, which is why part of the matter still survived. If you ever go into space, don't take off your spacesuit unless you're on a spaceship. Air in your lungs would expand, as well as the oxygen in the rest of your body. You'd be like a balloon, twice your regular size. Good news, the skin is elastic enough to hold you together, which means you wouldn't explode. Small comfort. When something goes into a black hole, it changes shape and gets stretched out just like spaghetti. This happens because gravitational force is trying to stretch an object in one direction, but at the same time squeeze it into another, like a pasta paradox. Speaking of, a black hole that's as big as a single atom has the mass of a really big mountain. There's one at the center of the Milky Way called Sagittarius A. It has a mass like for a billion suns, but luckily it's far away from us. If you made a big boom on an asteroid, you'd never be able to hear its loud sound. Yes, we often hear the sound of spaceships and battles in space in the movies, but that's just a myth. Sound is a wave that spreads because of the vibrations of molecules. A person claps a few feet away from you, the sound wave begins to push the first air molecule next to the clap, then the second, third, and so on, until the wave reaches your ear. So, to spread sound, we need molecules like air or water. In our atmosphere, sound waves spread out just fine, but space is a vacuum, so it's nothing here. You can clap your hands loudly there, but there just won't be any molecules that can vibrate and carry that sound. So, to carry on a conversation, you'd either need a radio or really good lip-reading skills. Meteoroids orbit the Sun, while the majority of human-made debris orbits our planet. For example, we launched almost 9,000 spacecraft around the world from satellites to rocket ships. Even the tiniest pieces can damage a spacecraft at such high speeds. Galaxies, planets, comets, asteroids, stars, space bodies are things we can actually see in space. But they make up less than 5% of the total universe. Dark matter, one of the biggest mysteries in space, is the name we use for all the mass in the universe that's still invisible to us. And there's a lot of it. It may even make 25% of the universe. Dark energy makes the other 70% of the universe. That adds up to 100, right? Now, let's look at the moon. It always looks at us with one side. This means the moon has a dark side and the sun's rays never get there. Well, that's a myth. The whole point is that the moon is gravitationally locked to the Earth. There are days and nights there too. It's just that this rotation is perfectly aligned with the rotation of the Earth. So whenever you look at the moon, you only see one side. Although there are days when the sun shines there too, so it's not the dark side, it's the far side. And we even have pictures of this place. And there's one of the biggest craters in our entire solar system. The South Pole Aiken Basin is as wide as 2 states of Texas. Yeehaw! One myth that turned out to be untrue is that people have never actually been on the moon. This is the original spacesuit of the first astronauts who were there. Look at the sole of the shoe. Some people claim there's no way they could have left footprints like this there. Actually, they could. On the moon, the astronauts wore extra boots over their suits, and their soles matched the footprints on the moon perfectly. Now, the astronauts didn't need them when they left the moon and tossed them when the moonwalk was over. They left a lot of stuff there, too. They even tossed the armrests of the seats in the lunar module to reduce the weight. Now, counting all the Apollo lunar missions, the total weight of rubbish on the moon is approximately 187 tons, including several lunar rovers, spacecraft debris, 6 lunar modules, and all the experiments left behind. That's like 3 Boeing 737s. Another myth about the sun is that it's yellow. Let's send you into space for this one. You look out the window and it's white. The sun only appears yellow to us through the filter of our atmosphere. The composition of the air and its thickness just distorts the light of the star. But stars do come in different colors. Cooler stars have bright orange and red colors. These are usually very old stars, older than our sun. But young and very hot stars are bright blue. The sun is about in the middle of this spectrum. Oh, one more myth about asteroids. We need to fly a little farther than Mars's orbit. Whoa, we're in an asteroid belt, and we constantly have to dodge giant rocks and blocks of ice. We got in some dense asteroid clouds. Not true. The fact is that space is huge, and the distances are incredible. All the rocks and debris in the asteroid belt are only 4% of the way to the moon, so there really aren't that many of them there. To understand the dimension of the emptiness in space, look at the collision of two galaxies. There are billions of stars in each of them. If we mix them up, it's unlikely there will be any collisions even here. It was 1994. It was dark, so no one saw two silhouettes opening the emergency exits of a glass dome complex in Arizona known as Biosphere 2. They were determined to free 7 people locked inside for a month, risking their lives in the name of science. The mission was accomplished, but they got hit with trespassing and vandalism charges. The vandals were Abigail Ayling and Mark Van Thillo. They were among the first 8 poor devils who lived in that place as guinea pigs, and they didn't want anyone else to go through the same horrors they had experienced. $150 million were spent to see if humans could create suitable living conditions on other planets, like Mars. To do this, scientists built a mini-world with over 3,000 species of plants and animals. Biosphere 2 was a sealed-off 3-acre habitat, complete with its own mini rainforest, a private beach with a coral reef, a grassland savanna, a marsh, and even a desert. Between 1991 and 1993, nothing could enter or exit that place. The group of 8 people locked inside called themselves Biospherians, rocking matching Star Trek-like jumpsuits, growing their own food, and breathing their own air. They began with high hopes and a 5-star hotel-style breakfast, but things took a darker turn over the months. The whole team was starving and turning orange. In Biosphere 1, which is the real Earth, you can order a pizza in 2 minutes. But inside Biosphere 2, it took them an endless 4 months to whip up a margarita-style pie. They had to harvest wheat for the dough and milk goats for the cheese. The goal was to be completely self-sufficient, and they became part of an atmosphere, quite literally. When they breathed out, their CO2 fed the sweet potatoes they were growing. And those sweet potatoes became part of them since they were essentially eating the same carbons over and over again. They had so many sweet potato feasts that their skin actually turned orange from all the excess beta-carotene. What seemed like a funny situation at the time highlighted a big issue. The crop yields in Biosphere 2 were a total disappointment, and the crew was starving. They were going crazy from hunger, and moments of sudden anger led to doing regrettable things, like stealing bananas from the basement storeroom. At some point, the freezer had to be locked. Over the first 6 months, each of them lost between 18 and 58 pounds of weight. Every day, someone took charge of weighing out fresh food for the cook, logging the information about nutrients into the computer to make sure the crew hit their recommended calorie, protein, and fat goals. Initially, meals were served buffet-style, but as the crew got hungrier, the cooks started to meticulously divide their food into equal portions. Their diet, mostly sweet potatoes, carrots, fruits, and occasional meat on Sundays, were supposed to keep them going during those exhausting 80-hour work weeks of heavy physical labor. Biospherians were leaving every meal still hungry, and they had recurring dreams of McDonald's hamburgers, sushi, Snickers bars, and cheesecake. The air was running out. The entire place was completely sealed, with steel and glass at the top and a solid steel floor underneath. Managers made sure to check everything coming in to avoid synthetic materials emitting harmful gases. Living areas were furnished with wood and wool, and they couldn't use chemical deodorants or blow out birthday candles. Biospherians were counting on the food they grew and their many rainforests to produce enough oxygen for them to survive. However, they were losing oxygen very fast, drowning in their own carbon dioxide emissions, and worst of all, they had no idea why. With another 9 months of the experiment to go, oxygen levels had dropped from 21% to around 15%, which feels like living at the top of Mount Fuji. They felt awful, basically dragging themselves around the biosphere. They couldn't even finish a sentence without stopping to catch a breath. Then sleep apnea kicked in, with some of them waking up gasping for air. To bring down the carbon levels inside Biosphere 2, they tried some desperate moves, like growing plants like crazy, cutting back on watering the soil as much as possible, and even giving up on tilling. Nothing worked. So everyone decided they had hit a dangerously low point and asked for help. Refrigerated trucks showed up to pump more pure oxygen into Biosphere 2. As soon as the gas started flowing in, they burst out laughing and began running around. The ecosystem was a total mess. Hummingbirds and honeybees vanished after a couple of months, so plants weren't getting pollinated anymore. Worms and broad mites attacked crops, and cockroaches just took over. 4 species of cockroaches were brought inside to recycle organic matter, but the regular household cockroach was the ultimate survivor. They somehow sneaked in and multiplied, becoming a serious threat to crops. At night, the kitchen got flooded with cockroaches as soon as the lights went out. To combat the infestation, the group greased coffee mugs with lubricant and put pieces of papaya inside as bait. Roaches would climb inside, but they couldn't scale the slippery sides to escape. Being hungry, lacking oxygen, dealing with bug infestations, that's enough to make anyone go nuts. Heated arguments led to cups being thrown and people being spat at. Eventually, the whole group just split into 2. They stopped talking and could walk right past one another in the hallways without even making eye contact. Half of them wanted more food and oxygen to continue the research with some dignity, while the other half believed in survival without external help, no matter the costs. The truth is, the sealed chamber had been breached long before that. Just 2 weeks after they got inside, a biospherian named Jane Pointer cut off the tip of her finger in a cooking accident while making rice. The mission's doctor tried sewing the tip back on, but it didn't work, and her finger turned black within days. She went to a hospital outside for surgery, and a couple hours later, she sneaked back inside, carrying a duffel bag filled with supplies like computer parts and color film. Reporters would only learn of that sneaky delivery months later, and because of that, many people have questioned the credibility of the entire experiment. Media treated the experiment like a reality show, branding it as trendy ecological entertainment. Headline news around the world made it sound as if they were on the brink of losing their lives, to the point where families were concerned, calling the biospherians to check if they were really okay. The group felt like they were in a human zoo, with tourists coming from far away to peer into the glass cage. In the first 6 months alone, more than 150,000 people visited the place. Biosphere 2 ended up becoming a pop culture punchline, inspiring a comedy movie called Biodome and decades of funny sketches. You might be wondering why none of them quit the experiment and walked out the front door. Well, none of the environmentalists wanted to be the first to admit it was too much to handle. Plus, they were all still hopeful they could somehow crack the puzzle of building Earth number 2. By the end, they had managed to find 7 tons of missing oxygen. It had been absorbed by the concrete. Even though being breathless all the time might seem like the biggest challenge they face, the biospherians said that learning how to deal with people in a closed environment was even harder. It looks like the experiment was a huge failure, but the group did learn a lot of valuable lessons. They proved that a sealed ecosystem could work for years. They contributed to studies on reef restoration, and their farms showed that high productivity and full nutrient recycling could be achieved without toxic chemicals. In case you wonder, this wasn't the end of the glass complex. The second mission inside Biosphere 2 took place in March 1994. Now, you can go back to the beginning of the video to understand how that worked out.
Space, the final frontier. It's a vast and mysterious expanse that has fascinated us for centuries. But as much as we've learned about it, there are still plenty of things that we've been lied to about when it comes to space. Let's take a look at some of the biggest lies we've been told about this topic. First off, we have the idea that space is just this pristine, untouched wilderness. But that's not exactly true. We've been littering space with our debris for decades. Everything from old satellites to rocket parts. In fact, there are over 20,000 pieces of debris orbiting Earth right now, and they're causing all sorts of problems for future space missions. So if you're planning on visiting space anytime soon, Watch where you go. You never know what kind of garbage might be floating around. Did you know that the sun is not actually yellow? It's green. Well, kind of. You see, scientists measure the temperature of a star by the color spectrum it emits. Cooler stars appear red, while the hottest of stars look blue. Our sun emits most of its energy at a wavelength that's close to green. But because it emits other wavelengths too, all these colors mix together, and your eyes see this vibrant mixture as white. From Earth, however, the sun looks yellow because our atmosphere is really good at scattering blue light. If our star was actually yellow, Earth would become a frozen rock, and we'd all be polar bears. Plus, the sun isn't on fire for real. It's a big ball of gas, mostly made of hydrogen and helium, and it works more like a gigantic nuclear reactor, constantly fusing hydrogen atoms to create helium inside its core. This process releases enormous amounts of energy. That's why the sun is so hot. Oh, and speaking of setting things on fire, explosions in space aren't real. Sorry, Star Wars fans, a spaceship can't go down in a violent blast because there is no air out there in space. No air means no oxygen, and no oxygen means no fire. Now, you might also think that there are too many stars in the night sky for you to count, but in fact, you can do that. According to the Yale Bright Star Catalog, there are 9,110 stars that you can see from Earth with the unaided eye. So, technically, you can count them, but I wouldn't be surprised if you lost count. And if you're worried about flying through an asteroid belt, don't be. Although it does have trillions of space rocks that range in size from space dust to a quarter of the size of the Moon, they're very spread out. The asteroid belt between Mars and Jupiter is 140 million miles across, which is 1.5 times the distance between Earth and the Sun. This spreads space rocks thousands of miles apart, making it almost impossible for a spacecraft to collide with one. You'll instantly freeze in space without a suit. Nope, you won't turn into a popsicle right away. It's gonna take a bit longer than that because heat and cold don't really move very quickly in the vacuum of space. But unfortunately for you, there's a bigger problem at hand. You won't be able to breathe. After just 15 seconds, your brain won't be getting enough oxygen from your blood, and you'll pass out. And then after just 2 minutes, it's curtains for the rest of your organs. So, in short, if you find yourself playing astronaut without a spacesuit, it's game over pretty quickly. Did you know that space doesn't have any temperature at all? That's because the temperature is defined by the speed at which particles move and the amount of energy they have. In the true vacuum of space, there are no particles to move around, making it temperatureless. Of course, some parts of space are really hot, like areas around stars. But the further away you get from stars, the more spread out particles are, making those areas of space pretty chilly. Number 9 is our planet's shape. No, it's not flat, but it's not a perfect sphere either. Yeah, it bulges at the equator because of our planet's wild spin. It's like Earth is doing its own little dance. And because of this bulging, launching spaceships from the equator is much easier than from the poles. Now, when it comes to sound in space, it's a bit of a tricky situation. You might think that no one can hear you scream, but that's not entirely accurate. The thing is, sound needs something to travel through, like air or water. In space, things are super spread out, so all those epic space battles and galactic explosions would be completely silent. Yet there are some places in space with enough particles for sound to travel through. For example, you can hear the black hole at the center of the Perseus galaxy cluster. Another myth is about zero gravity. That's not a thing. There's still some gravity hanging around the International Space Station, about 90% of what we feel on good old Earth. But astronauts get to float around because they're basically free-falling around the planet. And let's be real, Hollywood's version of space travel is not factual. Sure, orbits are a thing, but different altitudes mean different speeds. so moving from one orbit to another isn't exactly a walk in the park. You can't just push yourself in the right direction and hope for the best. You gotta take those orbital velocities into account. This reminded me of the 2013 movie Gravity and how Sandra Bullock tried to survive in space. Hollywood sure added some fuel to these myths. Yet again, who can blame them? Back in 1976, NASA's Viking 1 spacecraft snapped a photo of a curious rock formation on Mars that looked suspiciously like a face. Some folks out there claimed that it must have been proof of extraterrestrial life on the red planet, but NASA had a different take. According to the space agency, the face was nothing more than a bunch of rocks piled up in such a way that the shadows they cast created an illusion of facial features. It turns out it was just a regular hill that got a little too much credit for being photogenic. The solar system stays in place. Lie! It's zooming through space at a speed of 140 miles per second, which means that it's whizzing through the cosmos faster than a cheetah chasing its prey. It takes us 230 million years for the solar system to complete a full orbit around the Milky Way. It's a good thing it isn't getting a speeding ticket, because that would be one astronomical fine. Eh? Without the sun, planets would be pretty chilly. We're talking about temperatures as low as -455 degrees Fahrenheit. Brr. But with the sun around, the planets get to enjoy much more livable temperatures. Of course, not all planets are created equal. Mercury, for example, is the closest to the sun. Venus, on the other hand, is farther away, but somehow manages to be even hotter than Mercury. The distance from the sun isn't the only factor that affects a planet's temperature. Other things like the planet's size and reflectivity also come into play. So Mercury being the hottest planet in our solar system is a false proposition. No, just because it's the closest one to the sun doesn't mean it's the hottest. Even though we've been deceived in some ways, that doesn't make space any less amazing. It's still a vast, beautiful, and utterly fascinating part of our universe. And there's still so much we have yet to discover. Who knows? Maybe one day we'll really discover little green people out there. Or maybe we'll find out something even more incredible. Until then, we'll just have to keep dreaming and exploring. There, you got 14 things on our list. Do you have any other space myths to debunk?
Now, think about the vastness of the universe. Our galaxy contains between 100 and 400 billion stars. Many of them can potentially host planets. Many of those planets might have water in them and be capable of supporting life. And this is just the Milky Way alone. What's the likelihood of other intelligent civilizations existing out there? Well, there's a famous formula called the Drake equation. It's a mathematical tool to guess how many civilizations from outer space might be able to talk to us in our Milky Way galaxy. It was made by a scientist named Frank Drake in 1961. Here are the variables in it. N is the number of civilizations we could potentially talk to in our galaxy. R star is how fast new stars are born in our galaxy. F sub p is the fraction of stars with planets around them. N sub e is the average number of planets around each star that could support life. F sub L is the fraction of those planets where life might actually start. F sub I is the fraction of planets with life that could become smart civilizations. F sub c is the fraction of smart civilizations that send signals into space. And L is how long those civilizations keep sending signals. Of course, we won't get an exact number like this. It's more like an educated guess, and we don't have any answer to that. But based on at least some information we know, there might be around 100 million worlds where life should have evolved. But if that's the case, then why haven't we met or heard from anyone? This is called the Fermi paradox. It's named after the famous physicist Enrico Fermi. He asked a simple but very important question: where is everybody? Our universe should be filled with chatty extraterrestrial beings, advanced civilizations, and spaceships zipping around. Yet, when we look up at the night sky or listen with our radio telescopes and antennas, it's eerily quiet. All we get is the so-called Great Silence of the universe. Scientists from Oxford University's Future of Humanity Institute are trying to answer this question. And they're not the only ones. A group called METI, for Messaging Extraterrestrial Intelligence, organized a workshop in Paris in 2019 to explore this mystery. The workshop brought together experts from various fields, like astrophysics, biology, psychology, and so on. One of the ideas discussed is called the zoo hypothesis. It suggests that perhaps other civilizations do exist, but they're simply not broadcasting their presence. Maybe they know that making direct contact with us could be risky for both sides, so they're intentionally avoiding us because they're watching us like observing a zoo. They could be using advanced technology we can't detect. There are also some optimistic explanations, like time delays. Space, as you know, is unimaginably big. The time it takes for signals or information to travel across the universe is enormous. It's possible that other civilizations exist, but their signals haven't reached us yet, or ours haven't reached them. But some explanations aren't very optimistic. Like, some scientists think Earth might really be unique. Maybe the conditions that led to life and intelligent beings are so incredibly rare that there are no other planets like ours. Scientists point out that there are many planets similar to Earth, and some are much older. This means there should be plenty of planets where life could evolve. Recent research also suggests that life might be way more resilient than we thought. And, well, while it increases the amount of life existing out there, it also increases the chances that intelligent life doesn't last very long. It might destroy itself before it can spread to other parts of the universe. This is a concerning idea for the future of humanity. The researchers also considered that many planets might be at a similar stage in their development. That's why it's hard for them to explore the universe at the same time. But even they agreed that this explanation is way too far-fetched. And finally, one of the big potential explanations is called the Great Filter. This idea was suggested in the 1990s by Robin Hanson. It says that for life to develop and become advanced like us, it has to overcome some really tough challenges. First of all, the planet itself should have a good stable star and good enough conditions on it. Then life has to start on that planet. These life forms need to be able to reproduce using things like DNA. Simple cells must evolve into more complex cells. More complex organisms with multiple cells must develop. And eventually, these organisms must figure out how to reproduce, which increases genetic diversity. And finally, these organisms must be smart enough to use tools, create, and explore things. Finally, they should colonize other planets and star systems without destroying themselves. And maybe one of these stages is so incredibly hard that most civilizations don't make it past that point. This challenge could be something like developing intelligence in the first place, or it might be the struggle to avoid self-destruction. So, perhaps life isn't rare at all, but most of it doesn't go beyond simple tiny organisms like bacteria. Even if the universe is full of bacteria, they don't become advanced enough to build spaceships. The Great Filter might also be something from outside, like a huge asteroid crashing into a planet, a dangerous burst of gamma rays, or a massive star going supernova. These events could destroy life on any planet, no matter how advanced they are. So, if we've already passed this challenge, it means we could be the only ones in the universe and we can explore it. But if we suddenly hear from a super advanced civilization, it could mean the hard part of the challenge is still ahead of us. Now, the Fermi paradox focuses on intelligent civilizations. It just implies that there should be civilizations more advanced than us, or at least as intelligent as us. But if you think about it, why should extraterrestrial life be similar to ours at all? It might be completely different for many important reasons. Life elsewhere might have developed under completely unique conditions. This could lead to forms of intelligence and consciousness very unlike our own. For example, it could have evolved into highly advanced forms that aren't based on biology as we know it. These beings could exist as energy-based entities, silicon-based life forms, or even as a hive mind. And because they have evolved completely differently, they may be capable of things that we aren't capable of. For example, we can't see the entire light spectrum. Our eyes also can't perceive cool things like dark matter. But who knows what the vision of extraterrestrial beings may be capable of? Their abilities might even extend beyond our three-dimensional perception. They might be able to perceive and interact with higher dimensions, which is why they could have unique, interesting insights into the nature of our world. Or maybe they've learned to think outside of time, like in the movie Arrival. For us, we still haven't met them, but for extraterrestrial beings themselves, the concept of time doesn't exist at all. They're simultaneously in the past, present, and future. For humans, something like this is hard to even imagine. Plus, even on Earth, we don't fully grasp how consciousness works or why it exists. We're not even sure when exactly we became conscious. So even if we do encounter extraterrestrial life, it will be hard for us to understand them or communicate with them. We think that they might have entirely different language systems, symbols, and so on, but they might not even have any communication systems at all. As you can see, the possibilities are endless. Evolution is a process that can go in many different directions. It's possible that extraterrestrial life developed in ways we can't easily understand or even imagine. These things are intriguing to think about. There are still no easy answers. The Fermi paradox remains one of the most exciting and mystery questions in science. Scientists continue to explore these mysteries through a multidisciplinary approach. They're hoping to find clues that could lead to breakthroughs in our understanding of alien intelligence. And until we find a definitive answer, we can keep sparking our curiosity and imagination.